The cosmic onion. What is this cosmic onion? Well, we're going to peel off the layers of the universe and go deep into the heart of matter, trying to find the smallest pieces out of which everything is made. You, me, the whole show. Now, the outer layer is what we see with our unaided eye. But we're going to go deep inside, taking off the top and peeling away the outer layers to find the atom. Now, atoms we can't see with our unaided eye, but we'll see later on how to show them. And the atom isn't the end of our story either, because inside the atom we find the nucleus. And the nucleus itself contains smaller particles. And eventually, deep, deep down inside, you have the quarks, the primeval seeds of creation. As you can tell, onions grow better in a damp atmosphere. Now, these were formed at the very start of time, when the universe was very hot. As it cooled down, they were hidden inside the atoms, and eventually hidden totally from view inside matter as we see it today. So that's one part of our journey that we're going to take. We can look at the journey in another way, in a journey going back in time. Because here now today, it's 15,000 million years after that original Big Bang. The universe is very cold now. The atoms like carbon and oxygen, nitrogen, iron, the sort of things that we find around here and that we're all made of, they were formed in stars that died away only about 5,000 million years ago. I say only. That's very recent in the whole time scale of the universe. Now, those oxygen atoms themselves were cooked much earlier. The hydrogen that was formed around 300,000 years after the start of the Big Bang eventually fused in the stars to produce the oxygen that then was exploded at about the time when the solar system began, polluting the cosmos, ending up in you and me. So we're made from the remnants of a dead star. I didn't say that these lectures were going to make you necessarily feel very good. So hydrogen formed about 300,000 years after the Big Bang. Now, before this time, the universe was so hot that the individual pieces of the hydrogen atoms were all whirling around all over the place and just couldn't hang together. It was only after this amount of time that things had cooled down enough that the hydrogen atoms could hold themselves and eventually end up here today. Now, the nucleus of those hydrogen atoms, they were formed within 3 minutes of the Big Bang. And we're going to go back even further than that, right back to the first second, and even before that, to the moments when the first seeds of creation, the quarks, were being formed. So we're like archaeologists in a way. We're raiders of the lost quark. Now, you might think that we know all about it. You keep reading in popularizations and in films that the theorists are about to write down on a single sheet of paper the equation that describes the universe. Everything. That we know how the Big Bang happened. We don't. Nobody has ever been there. Nobody knows what the Big Bang was like. But what I'm going to do is to take you on this journey as near as we can get to it so far. And we'll see the signposts along the way and see step by step what we do know. And we can get very, very near to it. So to start the journey, I thought I'd give you an idea of how long 15,000 million years is. I mean, here we are today. How long ago was then? So let's start the journey like archaeologists. They're much more friendly sounding people than particle theorists are, but I hope you won't think that at the end of the talk. So let's start going back. You can dig up history out of the ground. That's what real archaeologists do. 100 years ago, that's a long human lifetime. That was before modern science began. 1,000 years ago, the Norman Conquest. 100,000 years ago, we start finding remnants of early ancestors. And here on the table, I've got a human skull, 100,000 years old. And the producer of this program said to me, tell them something about it. I said, well, what do I tell them about it? It's 100,000 years old. And he said, well, read the label. I read the label. It says Dudley, Worcestershire. So this obviously tells us this person was called Dudley and he comes from Worcestershire. Or maybe he comes from Dudley in Worcestershire. Anyway, this is a 100,000-year-old human skull. 100,000 years, 100 million years, the age of the dinosaurs, Tyrannosaurus Rex, the famous movies, you all love them. This is a piece of dinosaur dung, fossilized. It comes from India. 500 million years ago, these are the earliest fossils of living things that you will find. This is a trilobite, a sea creature. It also was found in Worcestershire. I don't know why Worcestershire is getting so much profile here. I don't come from Worcestershire, I come from Peterborough. We've got much older things there, as we will see in a minute. It also shows that Worcestershire has changed, that it was once under the sea. So we can go back 500 million years and dig up things out of the ground, and we're getting on our way. 500 million. But that's still only 1/30 of the way to the Big Bang. Let's take a big step. Because I said there's even older things in Peterborough, and there's even older things in this room right now. Let's all relax and get warmed up. Take a deep breath. Let's do it again. You've just breathed in oxygen atoms that are 5,000 million years old. Because the air has been here since then. In fact, the air has been here that long, and water has been here that long. This water is 5,000 million years old. I shall now drink some. Not bad for 5,000 million years, but it gets recycled quite a lot. Now, the thing about water is that in addition to this 5,000 million year old oxygen, it's got some of the primeval stuff of the universe. And what we're going to do is to extract it. Now, Bryson has set up an experiment over here. We've got this glass here with water in it, and we're passing electric current into it, and you can see it bubbling away. It's splitting the water into its basic atomic components. And it's bubbling away and being collected in this vase here. Now, what we're going to do is put some soap on my hand, first of all, and then we're going to transfer this primeval stuff to it, bubble by bubble. But the point of the soap is to stop it escaping, so it doesn't float off out of the atmosphere straight away, until we've got enough there. So in my hand, I'm holding some of the original stuff of the universe. Now, I know what you're thinking at this moment. You say, oh no, just a second. Look, it doesn't look like anything at all. It looks like air. What's going on here? This is not air. This is different stuff, as we shall now show you. Thank you, Bryson. That was hydrogen. Hydrogen atoms formed long, long ago, only 300,000 years after the Big Bang. So we're well on our way now, and we will eventually go back even deeper back to the Big Bang than that. But I want to show you as we go along that we can actually see these things. Because what these lectures are really about is seeing the universe, what we have to do to reveal the basic atoms, the basic things of matter, to take that journey back to the Big Bang and be convinced along the way that it's a real journey, that we can see the signposts as we go. So that when we arrive there, you know you've taken the journey. So the first thing really is, what do we do when we see things? We're on the trail of atoms and molecules today. So what's involved in actually seeing those atoms and molecules? Well, we see with our eyes, for example, light shines down onto me at the moment, bouncing into your eyes. So there's a source of radiation, the thing you're looking at, and your eyes will detect it.